Hey there, today we'll be doing this question that appeared in Leetcode Biweekly Contest 100 2592 maximize greatness of an array. Given question statement is you are given a zero indexed integer array nums. You are allowed to permute nums into a new array perm of your choosing. We define the greatness of nums to be all the indexes I for such that permutation of I is greater than nums of I, and we need to return the maximum possible greatness we can achieve after permuting nums. So let's understand this question statement with an example. So the question statement says that whatever nums is given to you, you can rearrange the elements in any manner for a new array. Fine. And you need to make sure that in that array, that is new permutation array, the value of nums of I, and for the correspondence value of nums of I also, permutation of I and nums of I, the value of permutation of I is strictly greater than nums of I. So if we put 4 here, then we can see we can get such a value, right? And we can get a greatness of 1 for now if we do this. Now, how to actually approach this problem? So for this problem, we'll just simply use a greedy and a two pointer approach. Greedy being we just sort the array, and two pointer approach we'll see to it. Now why sorting, we'll understand this later, which is a very easy point, but let's understand how do we do it using two pointer approach. Now at first, what the two pointer approach says is you skip two pointers on the same indexes, and we'll come to the intuition just after we dry run this. Once you understand this properly, if you understand this properly, you'll automatically get the intuition. Okay, so let's understand this first. We have ing pointers. Now we'll check is the value at nums of I and nums of j greater in any manner. That is the value of nums of j, whatever is there, is it greater than nums of I? So is 1 greater than 1? Obviously not. So let's move ahead. So we move ahead to this point. Now we see the value of nums of j, that is 2, is greater than 1. So what can we do? We can say that okay, at permutation of index 0, I can actually put a 2 here. Now this is done for. So now we can move both the indexes by 1. This is what happens, 2 and 3. Now what do we have? We have 3. Now we can say that 3 is greater than 2, obviously. So we can actually put this also right here. So we put this right here. Now we move both the indexes by 1. That is 3 and 4. So we see 4 is greater than 3. So we can also put this here. Now, if we see, we are just left with a blank right here, because after this 3 and 4 iteration, what will happen? We'll move ahead by 1 and we'll go out of the bounds. So there's no point in doing it. So we see there is a blank right here which is left here. So that means we can only make 3 greatness, that is make the array's greatness as 3. Now I hope you have got the intuition, but if not, let's just see once more. So the intuition simply lies behind the fact that we'll try to greedily choose the nearest greater element for some element. Now to simplify this statement, for 1, what is the nearest greater element than it, which is nothing but 2. So that is why we chose this. Now for 2, what is the nearest greater element? That is 3. And for 3, subsequently 4. Okay, so this is the whole intuition. All you have to do is just simply make sure you choose the nearest greater element that you can find out. And if you do this, we'll be getting a proper answer. And why sorting? You must have obviously gotten it, because if we need to find the nearest greater element, you obviously have to sort it. Otherwise, a random array, we could have something like this, and which would cause some issue, right? Obviously. So that is why we need to sort it at first. Now coming on to the code, it is very simple. At first, what do? We just sort it. After that, we initialize two pointer, that is I and j. We run a while loop. We see that if nums of I and nums of j is satisfying the condition, that means if let's just say I is here and j is here, what do we see? We see that 2 is greater than 1, so it satisfies the condition. So we move both I and j by 1. We move both I and j by 1. That is the initial statement. Now if something happens, that is we are here, that is I and j is here. Now I is greater than j, that is 1 greater than 1? Obviously not. This condition does not satisfy. So what do? We try to make sure that we try to find a new j for r such I, right? That is, we move our index. That is what we do. So that is what we have done right here. If nums of I is less than nums of j, that is, we do not find a greater element in my nums array for a particular permutation. What do? We just make sure we increase the I by 1, and we are taking care of the count in this count variable right here whenever we are finding a permutation for that index. And at the end of the day, we just return count. So this is the whole code walkthrough as well. If you want the code, it will be in the description as well. And if you did understand this whole explanation, please do like and subscribe. And yeah, thank you.